In our minds, OOP is the current king. Everybody writes in object-oriented code. There are multiple languages that has object-oriented programming included in their core functionality. So basically, you have to write object-oriented code if you want to be considered a professional developer. There is no other way. Yes, if you are some kind of the nerd on the university, you can try to write different code. But if you want to create commercial applications, you have to do it object-oriented way, right? So this feeling is so strong that I had a meeting with my friends a few days ago. They mostly write in Java. When I told them the subject of the presentation that I want to present, they looked at me like this and asked me if I'm sick or drunk or both, because this is madness, right? But is this true? Why do we use object-oriented programming, like for real? The idea was that it will help us to fix the common problems with our code. It will help us to create good code, encapsulated, well-structured, easy to test. But all those things are not connected to object orientation at all. You can write a very good code not using objects, and you can write a terrible code using objects that is fully object-oriented. So. And good practices are not something that is unique for object-oriented programming. So what's wrong with object-oriented programming? As you can see here, the sentence from Joe Armstrong, which is a very clever guy, but mostly writes in Erlang, I suppose. This explains a lot. So he said that the object-oriented programming was meant to be a banana. But instead, we've got the gorilla holding a banana and the entire jungle. So it was meant to solve the simple problems, but the solution is more complicated than the problems that were meant to be solved. And the first confusion is, what does it really mean that your code is object-oriented? So this might seem to be simple, but for real, is it only about using objects? That's not, because you can use objects in your code and your code won't be object-oriented. So there are multiple definitions, half of them are wrong, but I think we can all agree that object-oriented code is using classes, is using inheritance, and is created with objects in mind, so it's designed around objects. Right? So let's start with classes. Don't write classes. Classes in JavaScript, first of all, are optional. We don't need those. In Java, you have to create a class if you want to create an object, unfortunately. But in JavaScript, you can create objects directly. We can just ignore the classes and create an object, and then modify the object, augment it with all the attributes we want to have inside it, and use it directly. What's more, classes in JavaScript are broken. When you look at the syntax of the class, it's terrible. I want to create a class. So what I have to do, I have to create a function that will be kind of the class, and it will be constructor. And then I have to call it, but with the new operator, because if I don't use the new operator, it will break totally. And then we have this prototype attribute that is something that magically happens to be included in the prototype chain somehow, but it's not the same as the prototype chain. So when I perform workshops and I teach people the JavaScript, this is one of the most confusing parts. What the hell is this? This is a class or what it is? So syntax classes syntax in JavaScript is broken. It looks like someone at some point said, well, I've created a nice language, but I have to add classes so it looks more professional. And here they are. So, but what's more, classes are hard to extend. It's hard to add the new functionality to the class. The basic example, we have an array. We created an instance of the array, we have some built-in methods. But all right, I want to use other methods on the array. I need some new methods. We had this problem till ECMAScript 5 was introduced, so basically array was useless and the methods of the array were nothing more than just push. So now we have map for each, but I want more. So how can I add additional functionality to the RI? Well, I can't. I can monkey patch the RI prototype, but it's a terrible pattern. I can create my own class, some kind of custom RI or collection, but still I will have to wrap every single instance of the RI that I would like to use with my new functionalities. Or the most common approach, create some separated utils class and use it. So like basically like underscore does. But now some of the functions needs to be used by using the utils RI utils class, and some using the native class. Not really nice to see and nice to use. So additionally, thinking in classes and this idea that your code needs to be object-oriented leads to the proliferation of classes. A lot of developers create classes just in case, or they create classes that are basically useless. This is a very common example that I see, for example, in our technical interviews in the company. The candidates want to be so professional that they create class for everything. So we have a collection class. Well, it's a class, but basically it does nothing more than a native RI. But if you use this code, you have to browse through the class, find the documentation, debug it, look what's happening, and still it's useless. Or the class at the bottom, it will be inherited by all the views in your application. And it's empty, it does nothing. But I've created it just in case. Maybe in the future I will add some functionality to it. Yeah, so I will create it. It's, you know how it's called? It's premature patternization. Right? So don't create a class just in case. If you don't use it, it's not needed. And if you have such problems with adding new functionalities to your views that you have to create a class just in case, maybe it's something wrong with your code approach or with the style you are using. So what's more, many functions can be replaced by simple functions. Many classes can be replaced by simple functions, like this validator. Right? So we have a class that has basically has one method. If your class has one method and the constructor, you don't need a class. Create a simple function, shorter, easier, and it does the trick. So classes in JavaScript, in dynamic languages and in JavaScript for sure, are useless. We don't need those to create objects. We don't have types, so we don't have to deal with all this type checking. But we have to deal with cranky syntax and potential bugs. I suppose all of you are not able even to count how many times they forgot to use new operator, right? And they had nasty bug with the context. Okay, and yeah, one more. Classes, the main sin of the classes is that they mix the structure and the behavior. The data and the behavior of those data are mixed together, and you are not able to use those separately, like in the RI. So, and you will see how it inflicts the code you have to write. But let's go to inheritance. Probably all of you know what inheritance is. So you have some base functionality, and you want to share it with other classes. So you use inheritance. But inheritance is not a flexible solution. A very simple example, we have some components defined that all inherit after event emitter, they all inherit after base view, and they have some own functionalities. Very common approach to the GUI definition, right? And it works fine. But what if I want to add a class that does not fit the inheritance tree? I want my new class to be both floating view and the list view. It's not possible now. I cannot inherit two classes at once, not in JavaScript. We don't have multiple inheritance. So basically, if I want to solve this problem, I have to rebuild the whole inheritance tree, and probably break everything, and debug it, and create it from the scratch. So it's not a reusable code, that's for sure. And the debugging, more complicated, and this is not a huge inheritance tree. Probably every bigger project has much higher number of classes. And then you call a method on the instance of class K. So where is this method implemented? You have to browse through the entire tree to find the proper method and then check if it's not overwritten by some other method, and then check if it's referring to some parent functionalities, or maybe the attribute that it's using is defined in the base class, right? And then you have to change it if you want to add another class. So this is not flexible. Inheritance, in fact, is a set of hard-coded dependencies in your code that cannot be dynamically changed, that cannot be set during the runtime. And what's more, if you want to change those, you have to rebuild the whole set of classes. So this is terrible when it comes to the real use. Okay, so we are running out of time, so let's be quicker. Yeah, those solutions are not simple, are not reusable, and are not easy to maintain. You can create a very simple solution. Just create an object directly, use mixins that will augment the object with the functionalities you want to have, and work directly with objects. That's what we are using in our applications, big business applications for the bank industry. And it works. We don't have a single inheritance and class in our code. I just take a mixin that I want to use, and I apply it on my object. So I don't have to deal with all this inheritance tree. Yeah, and as I said, object-oriented programming was meant to be a cure. But the cure is more complicated and more problematic than the problems it was meant to solve. Let's take a simple strategy pattern. Very common, one of the simplest patterns in object-oriented programming. So basically, the idea is that we have a context that performs some action, but the action itself can be dynamically changed using the strategy class that implements some particular function. So let's quickly implement it in JavaScript using object-oriented approach. So we are very professional. So all we have to do, we create a context. Let's say it will be a calculator that performs some operations. So we can set the operation and perform the operation with the values. Right? So we create a base class for our operations with the abstract method. And then we only have to create an operation that will be used for real. So this adds two values. And of course, we need an inheritance. So we use some fancy helper that will inherit the base functionalities. And now, finally, we can add the two values. So we create a calculator, we set the operation, and we perform the operation. Voila. 3 classes to add 2 values. And I guess some object-oriented purist can even add 2 more classes to this schema, but I'm not good enough. And this how it looks when you use functions. 6 lines. Just a simple do operation function that takes the operation function as an argument. And it works. What's more, you can even use some basic function methods. Bind the attributes and save the configuration and then use it multiple times whenever you want. So you can compare those 2 solutions, and I guess the answer is quite obvious that this one is simple and very easy to reuse and to maintain. The best solution is simple. If the solution is more complicated than the problem you have, there is something wrong with your solution. Yeah, but what about thinking in objects? The very basic of object-oriented programming. Right, you have to reflect the objects, real-world objects in your application. But when you think about it, your application is not a static object. Your application performs some actions. You take some input, that may be a set of data from the database, or it may be a data provided by the user. You perform some operation, and you create an output. This might be another set of data, or the result displayed on the screen. So the function seems to be better representation of the applications we are creating. So of course, this is called functional programming. It's not a new idea. In general, it's about focusing on functions and objects should be used only to represent the data. And it has multiple paradigms, it has multiple rules when it comes to creating functional programming. But for me, I think the most important one, and the one that we can implement now, is don't mix data structure with the behavior. Keep them separated to make it more reusable. And this is exactly opposite what object-oriented programming does, because it mixes those two. Class represents the structure and has the hard-coded behavior inside. So let's imagine the JavaScript that is not that doesn't have this object-oriented programming add-on and has a decent functional library. So this is what it looks now. So we have array map, but it's mixed. Behavior map is mixed with the array that is a structure. So basically, in JavaScript, we have pseudo arrays that behave like an array, but they are not an instance of the array class. So this code won't work because arguments is not an instance of the array class, so it does not have a map method. So we have a method that can work with pseudo arrays, but it does not work because it's designed in the wrong way. So of course we all use this fancy trick that steals the method from the array class. But basically what it does, it says ignore this array, ignore those classes, ignore those methods, ignore this object orientation stuff. Take this attribute, take its value, and treat it like a simple function, and it will work. And since it's a very good interview question, it's not a good real-world solution. So the way it could be, our behavior, our functions, are separated from the data structure. Array stores data, but the behavior of the array is kept separately. So now we have methods, we have functions that can be used both on arrays and on the pseudo arrays. It can be used for arguments, it can be used on node list, it can be used on custom collection. You can apply the same behavior, you can apply the very same code on everything that behaves like an array. So it's much more reusable, even for this very simple case, right? So, but of course you look at this code and you say, okay, so we have a bunch of functions that are in the global scope. It doesn't seem to be a good idea. Of course, in real world, you would store those functions in a single object. So you would create basically something like _array. And still kind of lame solution if you want to create things in a functional oriented way, but you have to create objects to have some kind of namespace. So, but I guess for now we have to live with that. Although when I was gathering the materials for this presentation, I found a very interesting article, I guess it was on Duality blog, describing the final syntax of ECMAScript modules. And when I read it, I said, this is it. This is a perfect solution if you want to write a functional-oriented library. Because you can define all the methods, all the array functions in the single file, export those. Of course, these are all defined in the local scope. You can export those, and in the application, you can import only those functions that you want to use directly from the module. And you can use those for any structure you want. And you can do the same with all the other libraries. You can do the same thing with some custom array utils library and import those the same way you do it for native functions. So you can reuse those, and the way of using those functions is the same, both for custom and for native functions. So, yeah, and this is a reusable code when you can use the same function for everything you want. For everything that at least looks like an array, you can use the same solution. So there is something in the air. The tyranny of the object-oriented programming is ending, and the revolution is coming. There are new languages, kind of new languages, F# and Scala, that are big commercial languages created by corporations and created and designed to create a big commercial applications, right? So, and these languages are based around functions. Yes, you have objects there, but the main paradigm is a functional approach. What's more, even old languages, all those Java, C#, C++, grandpas, are receiving updates that introduce function-oriented syntax to those, so the developers can simplify their code. So they can get rid of all those object-oriented patterns and simply use functions to simplify this. And this all happens because people starts to realize that something that was meant to be a cure, a solution, is causing a lot of problems. So they're kind of looking for another approach. You've seen the functional reactive programming presentation, and this is one of the solutions. So what now? How can we live in the world without object-oriented programming? We don't need it. We don't need classes, we don't need inheritance, we don't need overcomplicated patterns. We can keep our code simple. We should think about actions that we want to perform, not this complicated structure, not the patterns that we have to use to be professional. And we should not mix the data structure and the behavior. Keep them separated and your code will be much more reusable. But most of all, don't be afraid to do things a different way. Just because everybody say that object-oriented programming is the only professional way to do it, doesn't mean that they are right. We can try different approach. We are lucky enough that our language allows for this. So don't be afraid to do things differently. And thank you. This is time for questions.
All right, so about 3 years ago, there was a lecture by Kevin Hannay. Do you know the guy? He is an expert on object-oriented programming, and from his lecture, well, he basically said that inheritance and polymorphism aren't really needed in object-oriented programming, and are more like distractions that are put there after the guys from Smalltalk invented the concept. And the most important thing is that you have this encapsulation, then isolates the state. He gave an example how to write object-oriented programs in C and Java, which isn't really easy, considering Java has classes. But I think that it isn't the right approach to do the functional programming on a large system without any kind of object-oriented design for the architecture, because it's easier to encapsulate different modules. And you gave this example of treating functions as traits that you can import in your object. Mm-hmm. But this is object-oriented programming. You have those functions as objects that you compose into an object that does the thing that you want. So it isn't the right thing to say the object-oriented programming is dead. It's just we understood it differently and it works in a different way.
Well, I guess it's a matter of definition. If the fact that object-oriented programming is changing into something new, it means that it's dead or it's evolving. Although, yes, functions in JavaScript are objects, that for sure, but it doesn't change the fact that the main advantage and the main functionality is not designed around objects. And, well, speaking about the inheritance, yes, that's true that object-oriented gurus are saying that inheritance is not a good idea. You should use more flexible patterns, which confirms the fact that it's not flexible enough. But still, even those patterns are too complicated when it comes to the simple fact like sharing the functionality. Although I'm not saying that objects are completely useless. Objects are a nice way to share, to store the functionality, and most of all represent the data. That's possible, that we are going to the roots, but also that we are simplifying something that was overcomplicated. So I guess we can say that object-oriented programming is evolving, or we can say that the standard object-oriented programming is dying, and there is a merge of new patterns. Maybe it will create something that is a mix of object-oriented programming and the functional programming. And I guess this might be the simplest solution to take something good from both.
Here. So my question is, why do you blame the concept of object-oriented programming for the crazy developers writing empty classes and all sort of crazy, terrible code you showed us?
I blame it because I think that it's somehow the reason they do it. Because I think that that saying that everything has to be object-oriented causes this kind of problems. Of course, you can write a better code and you can eliminate all the useless classes. But again, then you have a problem with adding new functionality. Like this base view example, yes, this class is useless. But on the other hand, if you have a whole inheritance tree and a whole set of classes you want to use, and then you really need to add a method to all of those, well, you kind of have to have some base class to do it. So yes, these were examples of the bad object-oriented code, but I think the dogma of object-oriented programming is causing a lot of such cases because it's overcomplicated. Our application, you should not think in objects and patterns. You should think how to create the most simplest solution to your code. And the good patterns like encapsulation, reusability, and stuff like this are not linked to objects, so you should not think in those.
Okay, so we are out of time, so we can ask questions later in person.
Yeah, you can catch me next to the Rule Financial kiosk. I will be there for sure. Thank you.